the results stand that Omdena showed us the way to work differently. And I think it's just, to me personally, it's impossible to go back the old way. I mean, I'm not going to go and order any studies from academicians in the university. Like, if I have funding, I'm going with people that work with Omdena. If they didn't figure it out, we'll find organizations that have figured it out. And Omdena shows that it's possible. So having one that makes it happen is enough. It means that it's possible. So that's the way I look at it. Thank you.
Okay, great. Well, first of all, thank you, everyone for coming. Good morning, good afternoon, good evening, from wherever in the world you are. I'd like to welcome you to our presentation today. I am Laura Clark-Murray. I'm the Chief Operations Officer for Omdena. And today's presentation is one in a series of demo days that we've been doing, where our AI and data science teams are sharing the results of our work. Today we're talking specifically about data innovation, our insights about tackling the data roadblocks that come up in real-world AI projects. First, I'd like to explain a little bit about the logistics of today's presentation, this 1-hour session. After this brief intro, I'll share a bit about Omdena, who we are and how we work, and give an overview on the data challenges that are inherent in AI projects. And then our presenters from the Omdena technical teams will be sharing the work on 3 projects, and they'll go into detail on the data innovation aspect of those projects. This will be followed by a Q&A session, and I would ask that you please post your questions in the chat throughout the presentations today, and we'll pose as many as we can during that Q&A session. I also want to point out that today's presentation is being recorded, and it will be shared on our website, omdena.com, afterwards. So just a few words about Omdena. We were founded last year in 2019 on a few key ideas. What if we brought together artificial intelligence and domain experts from around the world to collaborate on projects that matter to them, to give them the opportunity to do good work in this world? And what if they were given a framework and tools in which their work would be self-directed, with a bottom-up approach that might enhance their creativity and foster innovation? And what if we match those teams of AI experts with people and organizations who are facing these real-world and significant problems around the globe? And that's exactly what we've done. We've created a platform for teams of diverse experts to work together from around the world to build AI solutions to the important and challenging problems facing our world. In the 15 months since we've launched, we've executed on 24 projects across many sectors, and we've worked with partners including various UN agencies, NGOs, startups, foundations, and corporations. We've brought together almost 1,300 experts to collaborate in groups of about 50 people on our intensive 8-week projects, delivering deployable and actionable technology to these tough problems. Today, we're talking about the inevitable data roadblocks that come up in real-world projects. The insights we're sharing today come from our experiences. This is what's bubbled up out of the projects that we've done, and not just sort of high-level thinking. And hopefully that will come through today. So we've seen that the way that we approach AI development is making a difference in getting past the data roadblocks that will come up on these kinds of projects. And we're seeing that the approach that we take, where we are having very diverse teams, we're fostering this bottom-up collaboration, and having people work together in that way is what is driving the innovation behind this. So on projects, well, sometimes there is no data, and we don't see that lack of data as a showstopper. That's just the beginning. And if there isn't a data set, the team will ask themselves, well, what do we need to know to solve this big problem? And where might that data live? And if it doesn't exist, how can we create it from something that does exist? And here is one of the areas where diversity is very powerful. We've seen time and again the impact of bringing together people with vastly different professional and life experiences. Our teams are typically 30% or more female. And on any given project, we'll have 14 countries or more represented. Our collaborators range in age from 17 to 65. So by definition, they are bringing very different perspectives to the projects that we're working on. And this diversity not only leads to ethical and more trusted solutions, it fosters the creativity and alternative ideas about what data is relevant and where to find it. In the real world, data sets are rarely complete. And we find our large teams of dozens of people means that data gathering, cleaning, wrangling can all happen at incredible speeds. And also by taking a bottom-up approach. In other words, we're not defining how a project needs to go. We're allowing our teams, the sub-teams, to come up with their own ideas and drive development. And what this means is we'll have multiple sub-teams looking at data problems from different angles. This often leads to breakthroughs. And I think hopefully you'll see that today in the projects that we're discussing. And of course, relevant data doesn't typically come packaged in neat, tidy form. And also it doesn't come in just one form. So we often need to meld disparate data sources to get at a solution. Through collaboration, our sub-teams are can be focused on different separate data sets and using very different AI techniques. And through this collaborative process, come together to integrate the insights that they're deriving from the data. So underlying all of this is collaboration. And we believe, and we're seeing that the innovation on the data side and also with our models is inherent, or it is coming out of the diversity and bottom-up approach that we're taking and the collaborative approach we're taking. So today we'll be sharing 3 Omdena projects to get into some specifics. And while there are lots of things to talk about with these 3 projects, we've asked our presenters to focus on the data angle in particular. I'll just explain briefly what these 3 projects are, but our presenters will go into a little more detail. Will go into more detail. In this first project, we were looking at the effect of trauma on those in low resource regions. And specifically, could there be a way to assess for post-traumatic stress disorder among these folks so that they can be helped? Secondly, we worked on a project with Impact Hub Istanbul to look at how we might help families to reunite in the aftermath of an earthquake. How might we direct them onto safe routes through that city? And then finally, we worked with Safe City and the Red Dot Foundation to look at the issue of domestic violence in India, especially in this time of lockdowns. How might we use AI techniques to uncover the domestic violence that's happening behind the scenes? So before we get started, I would like to hand off to a colleague of ours, Erdem Ergin. He is a disaster risk management advisor for the UNDP. And we worked, he came to us as part of this Istanbul earthquake project and asked us to work together with their team on this problem. And I'm going to turn it over to him to give a few words about that. Thank you.
Hello. Thank you for the introduction, and thank you for pronouncing my name correctly. That was superb. So my name is Erdem. Greetings from Istanbul. I work with UNDP Turkey as their disaster risk management expert. And we were already in a collaboration with Impact Hub, which is a social entrepreneurship platform in Istanbul. And they actually told us about Omdena, and Rudradeb was in the city, and they had some talks. So the idea quickly came that this is a city of 16 million people, with a population of approximately 3 million children in education. So when you have an earthquake, and it's over two continents, there's Europe and Asia. It's a vast urban form. When you have an earthquake, obviously the idea of families getting back together will be one of the first priorities. And we thought, we presented the idea to Omdena, and they said that they'd be interested in hosting a challenge on it. So thanks to them, they brought the team together, and Anju, hello, I'm sure she'll provide more information on how the challenge unfolded. What I want to say is that we thought that we had a problem statement that was clear enough, but it wasn't. So that was a challenge that we faced, and the entire team needed to come up with that. Our original idea was that it's a mobility issue. We will take the schools as destination, where the children are, ask the list that we have the address of the school, and ask for the home address and the work address of the parents. So we have a data set that consists of where the parents are, either at school, either at work or at home. So then we can plan for journeys and length of time. The basic idea is that the schools need to know, if they have 200 kids, how many kids will be picked up within 6 hours, how many they need to cover for 6 to 12 hours, and how many they need to cover for a longer period, so they can plan for the stocks and to, to, uh, to, for the needs. But the problem statement wasn't clear enough, because we weren't clear about the assumptions, like, will the bridge fall, like how would people travel, like which mode, because that changed the length of the journey. And because of that, there was a lot of time that was spent. The challenge is 8 weeks, I think, almost half of it, and Andrew, please correct me, half of it was like, try to come up with a more proper and doable, pragmatic problem statement. And then, yes, the issue of data came up. The team did find data about soil types, earthquake intensity, etc., but not much about the roads, like what would be the situation of the roads. So they indeed showed flexibility and creativity, and in doing what is possible with what is at hand. So in the end of the challenge, there was a model for one district of Istanbul, and it was it was not a pragmatic model that can be deployed, but it really showed how, thanks to the working model of Omdena, it's just possible to do things differently, and I think that has a huge impact. It definitely left us hungry for more. So I'll leave it to that, and I'll leave to Andrew to elaborate more on the technical side of the challenge. But thank you, sincere thanks to Omdana and everyone who's participated and contributed to that challenge. Thank you, and over to you.
Thank you so much, Erdem, for that. Really appreciate that. And now I want to introduce Anju. Anju Mercian is a lead machine learning engineer for Omdena. She's also the director of Women Who Code Silicon Valley. And she's going to dive a little deeper into that particular project and discuss how the team got around those roadblocks, those data roadblocks. So over to you, Anju.
Hello, everyone. Thank you all for joining a demo day today. So I'm I've been spoken that the main thing that we tried to cover was how to get the parents to the children, right? So they can get children safety as soon as that we were looking at. So our main focus was getting parents to to children in schools. We ended up with that. So we had many things that were going on how to do that. So we came up with a lot of the team came up with a lot of the ideas, right? So first we were like, okay, let's take the soil composition and try to figure out if the soil is good enough, the bridges, the terrain, like how big the buildings are. So we had all these wonderful ideas, and we were looking out for data for that. We try to get soil composition data from various sites, but they were like not completely available. Like in a sense, they were not. First and foremost, the soil composition data wasn't up to date. It was and it was very sparse, so we couldn't use it. We couldn't find bridges data at all. There was one bridge that we knew, like when somebody said, "Hey, there's a bridge here," but we couldn't find that on Google Maps nor in any other maps, that we couldn't find the bridges data. So, and then we were trying to get terrain data to see through, like to figure out where the mountains were and trying to figure the height of the mountains, and then calculating based off the height of the mountains whether they were like how the terrain would be. But we were also very, very unsuccessful at that because of the fact that we couldn't get the actual data. And since it is geodata, not everybody are willing to give it to us. Soil composition data, actually, we found a place that could give it in Istanbul, Turkey, that have the data, but they wouldn't share it with us because we are not part of Turkey, and they have all their geodata, which is private data. Even bridges data, we tried Google Maps, and Google Maps was actually not. With Google Maps, actually, we had a problem with license. We had to pay to get license to get the data. And with terrain data, again, it was a geodata, it's private data, so we were not able to get the actual, what's actual data. So we faced that issue. So with that, what happened was almost like how Erdem said, we went 4 weeks trying to find the data, trying to collect the data. We found places where they may have the data, but they wouldn't give it to us. We mailed many people to get the data back. They wouldn't share it with us. So that was a big issue. So the first idea that we concocted, we had to drop, and we had to come up with a different idea to figure out how we can actually get to the place, how we can follow the shortest and the best, safest route to get from to get the parents from their place from point A to point B, which will be the school where the children are studying, right? And we looked at two data, trying to get data, geodata from Google Maps and OSM. One, Google Maps we couldn't go because of license issues. Even the free trial we couldn't use because that didn't have much data on Istanbul and the districts we were looking at for Istanbul. So we ended up using OpenStreetMap. OpenStreet was pretty good. OpenStreetMap data had a lot of the streets data, the dimensions of the road. All of that OSM was available. The only problem that we found with OSM was that it was very sparse. Not all of the areas were covered. It was not in depth that we wanted. Certain far away rural locations did not have much data for OSM, but we still had to go with OSM because that's the only data source that we had, the major data source that we had. So then we went ahead, and what we did was, then our idea was to get building data. So if there are more buildings in a particular area, we assume that that particular area may not be very safe because the buildings may have collapsed. So the distance to the buildings, that's what we looked at, the distance to the buildings from the roads. So we started calculating how the distance between the buildings, so imagining that would be the width of the road. And then we couldn't we didn't know the height of the buildings, so we just saw the sparsity of the buildings together. So if there are more buildings and the width of the road was smaller, then that was not a safe route. That's how we had calculated the safeness of the road, and that wouldn't have been the best because we don't know the soil composition there, we don't know how the terrain was, and we didn't know if there were bridges by any chance. So but still we were able to go with that, and that was a final solution where we went with the farther the building, the safer the route, and that was the safeness the density that we looked at. So what we did was we first got the graphs of the streets, and then we superimposed the street maps on it, and then got the shortest map by aggregating the vector lines and getting a moving average between the distances. So this was our pipeline steps that we did. We got the building coverage, the street width map, where we're calculating the different buildings, and actually we actually calculated through the with OSM we were able to calculate the I'm getting a lot of waste time, but I think there's a Q&A session at the end, so I'll leave it to Laura to explain that. Yeah, so then we were able to get the building coverage, I mean the width of the road to the buildings, and then saying how many buildings were there in a particular region. We had to do it in steps. We had to do it per area, a smaller area, and then integrate all of it, and then impose the heat map for it. So we only took one district for I think I'm pronouncing, I'm not sure how correctly to pronounce the district name. It was called Fatia. FATIH. So that was only district that we actually had wonderful data for some in OSM. Most of the other districts did not have all of the data. So with the building coverage and the street width map, we were able to calculate the risk map to figuring out how densely populated the street was. And then we did district to district for graph of streets, but we didn't do district to district, we just did road by road for the Fatia district. So some database querying. Then we got the risk score. We got the the street to distance warp, and with multi-objective path finding. So basically, that used A-star algorithm to find the shortest path. It was actually a combination of GFS and A-star algorithm. So we were able to find the shortest path, and this is what we were able to come up with the final demo for them. That they were able to use. I'm not sure if they will use, because this is what our idea was to come up with. So this is what we came up with at the end. Laura, over to you.
Okay, thank you so much, Anju. And just a reminder, I can see people are putting their questions in the chat, so that's perfect. And thank you, Erdem, for the.
You want me to answer them now, or just wait for the Q&A? Right?
We'll do that in the Q&A. So that would be great. Thank you so much. Okay, so now we're going to move on to the second project, and this one is the one I mentioned about assessing post-traumatic stress disorder among those who've suffered from trauma in low-resource environments. And in this case, our presenter will be focused on how the team went from no data to building models. And so I'll be turning this over now to Natu Lashand, an experienced machine learning engineer from Cape Town, South Africa. Thank you. Here you go, Natu.
Sorry, my name is Natu, and I'm based in Cape Town. And I'll be talking about the data challenges on the Omdena PTSD challenge that Laura briefed about. So basically, on this project, the main goal of the project was to prototype a machine learning-backed chatbot to help PTSD patients, and having the solution usable in low-resource settings, like refugee camps, war zones, and areas with lack of access to mental care. Sorry. Can everyone hear me? Okay. Cool. Second. Yep. So the critical barriers on the data side of this project were that we didn't have relevant public data sets. And there were obviously also ethical issues with the data. Can you actually treat or even dependably diagnose patients with the system? And should AI replace psychologists? And we also had privacy issues related with the data. and obviously like issues related with specific healthcare privacy rules and compliance. So the other issue that we had, so like our main strategy to mitigate the lack of data to build models was to initially decouple algorithmic research from data acquisition process by using generated or sample data available like online. So basically, the algorithmic team would be completely independent from the team that was aimed at collecting data. And obviously, having also team members like actively on their networks, like looking for data, because we had university professors, researchers in our teams, and we could actually like activate these networks. And we also evaluated at the same time data generation and augmentation techniques and techniques that didn't need a lot of data to drive. So we ended up having access to public domain anonymized data sets that could be used for this project by from a research institution. And also we had like normal challenges that we received. It was actually patient transcript data. So basically we had like obviously the normal bad data problems, and also like, let's say the transcripts, not all of them were related with PTSD patients. And initially we tried to like naively annotate everything to see like to produce the initial data sets for modeling. But it was like actually a very slow process because we had initially technically to annotate 3 million lines. So I'll in some way unveil like the process of like improving this process. So we used like Google spreadsheets to like annotate the data, and potentially you guys can see here like all the data annotation process. So we had like on each of the spreadsheets, we had like a transcript ID character, like it was like either client or patient, and we had the text. So it was basically a therapy script. And obviously we also had keywords like of the text, and there was some natural language processing on this data. So like the annotator could actually get some hints on which possible criterion or symptom of PTSD he was dealing with on that particularly scenario. So there was like since we had like psychologists on the team, so there was training so people could learn and understand. There were even video sessions created, so everyone could be on the same space for the data annotation process. So this is like one of the last iterations. One of the this is an example of a more detailed example of a spreadsheet where you have the different criterias, and you have the scripts as I mentioned, and you have like IDs. So as you can see, the data is completely anonymized, and in that way, like obviously we protect like the privacy of patients, and the data was like a lot of things were redacted on the data. So we also had to revise the goals of the project based on the data. We had to actually focus on risk assessment as like the most value that could be added by this data in the modeling process on this particular project. So we had to do a couple of things, as I said, to just like improve all the data challenges that I've described so far and our current status of the data annotation. So we need to be more efficient. We needed more support from domain experts so they could just summarize like the text, the data that we need to annotate. And we needed techniques to augment the data because like if we didn't have a lot of time to like annotate, we needed to be more efficient. And obviously use AI techniques that would leverage better like limited training data. So we ended up like tweaking the data annotation process, like with all the stakeholders in the table, and it ended up like basically reducing the annotation process from having to like hand label like 100,000 observations. We ended up reducing it to around like 1,300 by just like reviewing the data and creating scores for each of the transcripts instead of actually classifying line by line. And this was like the final type of data set that we had ready for modeling. And this was like one of the main like gains of the whole project. Like, so like the project could be unblocked from here. So that like going back to the last item of the data mitigation strategy. So using a transfer learning approach in natural language processing, this basically allowed us to leverage the data that was not annotated and obviously also leverage Wikipedia language models. And in that way, we could use like actually the name of the technique is few shots annotation. We can like then share links at given point. So it means basically with little data from your context problem, in even using unlabeled data, you could get to highly accurate text classifier models using like modern AI techniques. So in summary, so in this project, we analyzed the transcripts from PTSD patients, and we managed to create AI models to classify risks. So the main like items to summarize basically the reasoning behind and also the reasoning behind moving like from no data to model was like a problem definition carried into the data that we had available, and systematic, obviously expert guided annotation from domain experts, and being able to use both labeled and unlabeled data. So like I would stress here the unlabeled data, because like it's very expensive to actually annotate data, and particularly text data. So like being able to leverage at the same time labeled and unlabeled data like makes the process more efficient. And the other technique that we used, and the algorithms that we used allowed us to use, is called back translation. So you can basically automatically translate, let's say, transcripts in one language, for instance, English, and translate it to French, multiple languages, and then translate back into English, and you in that way be able to augment data. And yeah, and that's basically it at this stage. And I'll just like give it the presentation back to Laura. Yeah.
Thank you so much, Natu, and thanks everyone for continuing to post your questions in the chat. So keep that up. Okay, and now I want to turn to the third and final project that we'll be going in a little deeper on here. Harini Suresh will be talking about our project to uncover domestic violence in India that's hidden due to COVID lockdowns. As with all of these projects, the team looked at all kinds of things, and there were all sorts of challenges. But today, what Harini will be focused on is the challenges around the integration of data culled from very separate sources. Harini is a lead machine learning engineer for Omdena, living and working in India. So over to you, Harini.
Thank you, Laura, for that amazing introduction. So I'm Harni from India, and I would like to represent Omdena's third project using AI to analyze domestic violence and online harassment during COVID-19 with partners the Red Dot Foundation and Machine Learning India. So moving forward, the problem, what we encounter here is that COVID-19 has shown a marked increase in the cases of domestic violence and online harassment, particularly during lockdown. But most of the incidents are reported via calls, which makes data and subsequent mapping difficult. So the project goal would be data mining and analysis regarding the increase of online harassment and domestic violence cases in India, particularly. Our project is focused in India during the COVID period and doing a qualitative analysis on that. Now moving further, When we decide to build a model or an AI model, what do we first look? We look at the data, pre-process it, build a model, and go further with inference and testing and so on. But how about the building a model itself? Building the model requires data, and how we start with building the data as its own. This project mainly was focused on building the data, where we came across a few challenges, which we will be talking here. First of all, when we looked at building the data here, we choose the source, which is in particular with this problem statement: domestic violence and online harassment in India during COVID-19. And we collect the relevant data, pre-process the data, and check the validity if all the data collected is relevant to our problem statement or not, and integrate the various data sources, integrate the data which was collected from various data sources, and annotate them. This is the backbone of building the data in this project, since this is the way we teach the machines as to how to classify or how to extract the information. The machine doesn't know that this text information pertains to domestic violence. We teach the machine through annotations and prepare the data set, followed by pre-processing and building model. While we focus more on how we build the data for this model, there's these four categories which we took into consideration. Of course, reliable media. Isn't newspaper or the news TV channels giving us more insight on what is happening in the country about domestic violence and online harassment? Yes. Second of all, you are what you share. Are you upset? Are you sad? Or do you want to share your grief with others? It all goes on with social media, with tweeting or posting a status. And if you want to search, say for example, Omdena for that matter, what would you do first? Go ahead with Google. So I would like to search on how to cope up with domestic violence or police helpline numbers. So let's get into Google Trends. And after we all have to rely on our government for some data which can be relied upon, and that is the government data. Now, this is the data set. These are the data sources that we intended to collect the data from, ranging Twitter, which represents social media, Google Trends for us to support the other data sources which have been collected, and Reddit, following with government data, and of course the newspaper category split into regional and English newspapers for regional languages, throwing more insight on the rural India. Now, how is our data? Our data can be in the form of only text here, and it can be in the form of article or a tweet. An article, for that matter, will appear in the newspaper, and the tweet will be get out from Twitter. And we also have the Google Trends, where we search for help, police helpline number, and so on from Google Trends. Now that we have determined our sources, how do we intend to collect the data? The data is collected from Jan 2020 to May 2020, while our project began in the mid of May 2020 in India, with these certain keywords such as domestic violence, sexual assault, women, wife, bride, abuse, so on. So our data collection was in the form of web scraping, basically getting the information from the Twitter or newspaper data set with the help of these keywords mentioned here. How do we prepare the data? For this purpose, of course, we came up with our annotation tool, Docano, which helped us for this purpose, and we will be annotating the Twitter data. Twitter data is more of an opinion. It's more of a person's story, or it's more of a person's grief or happiness. So this is how we decided to separate our Twitter data into opinion, incident, and opinion info news, which may also point to a news. A tweet can also point to a news. While we dived deeper into Twitter, we also realized that news data is not similar to Twitter. Of course not. It is more of article, not about anyone's emotions or not about anyone's story, but actual fact as to what happened. In that way, we have certain labels which we came up with for the news data set to be categorized into. And that would be the labels described here. The prominent ones were domestic violence and online harassment, while we had measures and case progress for the other articles. Did the government come up with a measure to curb domestic violence during lockdown? Yes, it came under measures. Case progress, something which happened decades ago, and the judgment was given during the lockdown. How do we analyze the data? Be it a story in Twitter or be it an article in news, it's all about how we grieve about our experience in domestic violence or online harassment. And that's about analyzing from that piece of text which we got from relationship to the medium violence. So what was the relationship the actor and the survivor shared between them? What was the medium through which the harassment happened, the online harassment? Was it one of the popular social media platforms, or what was it? And we also have the violence verb, the age of the actor, age of the survivor, and circumstance taking effect, where was it the cause of unemployment, or was it just mere pressure which caused this drastic step of domestic violence? We use these following AI techniques for this project, which includes named entity recognition, which is the information extraction from the piece of text pertaining to the labels, which was mentioned in the previous slide, and natural language processing, which enables us to read a text and analyze it word by word to understand the context. And a classifier. We built a classifier to determine what that text meant. Was it a text pertaining to domestic violence, or was it a sexual harassment text, or what was it? What was that article based on? This is the series that we got from various data sources. We have the Twitter Times series, which also showed that domestic violence increased during lockdown, and the news data set. And we have the government data set, and we have the Google Trends, which supports our conclusion on these three data sets. Prominently, the biggest challenge that we were to overcome during this challenge is this integration of various sources and coming together for a data analysis from all these sources together. Of course, about the limitations, yes, we do have a lot of unspoken words. Most of the cases were recorded via calls. Do we record those calls, or do we have any way to access those calls? And yes, most of the rural areas might have been covered by the regional newspapers, but in case we miss those, we can get in touch with the NGOs particularly to that particular rural area, which will help us to have more insight on the rural area. And this is biased towards urban areas, saying that yes, domestic violence cases have increased in the metropolitan cities. But that's an understatement. We could not conclude because we might not have all the sufficient data from rural India, though we have the regional data, the regional newspaper data covering rural. This project summarizes building an AI model from building the data, with the foremost challenge being the integration of various data sources. How do we analyze as a one spot? Though we have data from Twitter, Reddit, Google Trends, and newspaper, how do we formulate it together? How do we bring it upon together, and how we had each data set support the other? This project was mainly built for tracking the domestic violence case in India, but of course, this can track domestic violence in various parts of the world. And the combining of different data gave us a broader scope on analyzing the urban and rural areas. The power of collaboration is summarizing all the three projects that we have discussed so far. Maybe one person had an insight on using Twitter data, but the other person thought that regional newspaper will cover rural areas. Why don't we have that? The other person had an idea about earthquake happening in their place, and they might have been a victim of that, which gave us more way of looking into it. There is always a diversity in the outlook of data, how we collect, how the data collection, diversity in the data collection, diversity in building the model obviously gives us very scope in building these three projects from scratch. And yes, finally, we would like to thank from Omdena to the Omdena team for making these three projects successful, given a short span of time, with collaborators ranging in 30 countries and 5 continents. Thank you.